So what's the problem we're trying to solve today, Scott?
We know what the different services should do. We've talked about this extensively, but they have to interact with each other. So if I go off and build, say, the sticker catalog and I build APIs, synchronous APIs, asynchronous APIs around it, you do the same for another service, say user management, they're not going to line up in the middle. We're going to get frustrated and angry and argue on pull requests for a while. And then eventually we're going to redo a pile of it. So I think we need to do something a bit more lower level with the planning.
And I think that integrating things together, at least in systems I've worked on, has been one of the trickiest parts. You think, yeah, we've got all these services and these things, and we've done this design, and it's going to be easy, and then it's not. And that's where I discovered this idea of API first design, which seems to be really interesting when I do conference talks. I'll always say, who's heard of API first design? And sometimes you get no hands and sometimes you get every hand. It seems to be pretty hit and miss. But the idea of API first design is that once you've kind of done this design to understand what the system actually needs to do and the different components of the system, the idea of API first design will be to design the actual APIs of the system. So we're going that next level deeper. And I think we should start with probably the most common thing that people think of when they think of the word API, which is synchronous APIs.
Yes. And here's one I've prepared earlier, which is the sticker catalog service. And I think it's a good one to look at because it's kind of providing a lot of the core functionality of Stickerlandia, which is saving and retrieving metadata and images for the stickers themselves. And you can see here, we can go ahead and grab the Synchronous API spec and have a bit of a look at what we've done. And for people following along at home, we've been talking about and iterating on this ourselves off to the side. And this is kind of the initial result of that process. Great. So when we look over here, we can see that we have a distinction between the synchronous and the asynchronous API, right? So I think the first thing we need to mention is that we have kind of a shared model of what should be synchronous and what should be asynchronous.
So it's interesting because we've got, the observant amongst you will notice that we've got under this docs folder, we've got two files. We've got api.yaml and async api.yaml. The reason we've done that is partly because the actual underlying specifications we're going to talk about, there's a specification called async API for asynchronous systems and a specification called OpenAPI for synchronous operations. But actually this maps quite nicely. In the last video in the series, we went through the idea of event storming. If you remember from that video, what we've ended up with is this idea of events that get published. So with the sticker service that Scott's talking about, we might have things like sticker created or a new sticker added or something like that. And then we've also got these commands and queries. Now, generally speaking, an event is going to be handled asynchronously and a command and a query are going to be handled synchronously. Now, that isn't always the case, but it is most of the time. So what this actually gives you is once you've gone from the domain story that we did in the first video to this event storm, to then now having a pretty decent idea of what your API of your system needs to be. So this is where you can use everything you've done so far, this reasonably lightweight level of design to start to really tease out what the actual synchronous and asynchronous operations need to be.
And I think to your point that this is a common practice, but it's not absolute truth. With anything like this, it makes sense to start on the rails, doing it the way that everyone else tends to do it, and then see if it fits. And as we go through this exercise in building our APIs, we can say, oh, maybe in this case, we want to make this synchronous rather than async or the other way around, but we'll just start from the position, I think, that is aligned with what you've just described.
Yeah, absolutely. And one of the big benefits of doing this, right, is that we know from doing the domain story and the event storm that there's going to be points of integration. Now, the theory is, and we'll get into the details of this in just a second, but the theory being that if Scott does the OpenAPI spec for the sticker catalog API, and for whatever reason, either a front end or another service inside the system needs to integrate with Scott's service, there doesn't necessarily need me and Scott to have a conversation like we are now. Scott can just expose his spec, I can expose my specs, and theoretically, we can all go off and work independently, which is kind of one of the things you're aiming for if you're building microservices, is to allow each microservice team to work completely independently. So this is kind of one of the ways you can help facilitate that.
Yeah, absolutely. And we would really like to jump to the programming part, but we're trying to make it so that the programming part is de-risked by making sure the parts where we have to align on decisions that cut across the services are made, basically. Like this video here is right on the interface between the common set of cross-cutting things we have to agree on for the project and the service-specific details. Like once we get past this, we can start moving the services forward independently of each other, which is, as you say, microservices.
So should we have a look at one of these specs now, do you think?
I've got one up. Let's have a bit of a poke. And the absolute first thing that we started discussing enthusiastically was scheme. And every project I've ever worked on, this is the first thing, because everyone has opinions about it. And you want it to be roughly consistent, right? Like ultimately, if you do this well and you have a set of microservices, you can mount them all up behind one common entry point and have them feel like a consistent API without having to do elaborate remapping, which is achievable, but kind of a pain. So it's worth investing a bit of effort up front in arguing about this, I think, front loading the misery basically. And then once that's done, going off and working on it. So we've gone with API because it's an API, and you can imagine that this would also facilitate us mounting a website, say, if you don't have the API prefix at the base of the path. And then the subdomain where we've got stickers here, and then a version. The way we've done it this way, we can evolve the versions of the sub APIs independently of each other, but we still have something that's going to look very consistent between domains, right? They all have the same root, they have the same format up to the version. This is a pretty common pattern, I would say. You also see ones where you have the version in front of the subdomain, essentially. This means that you have to version the entire API in aggregate, which is a bit of a bummer, I think, if you're trying to go really strong with the microservices. So we're starting off this way to keep things a bit more flexible. This one's straightforward. It's good to have health endpoints so that we have something we can plug into our load balancers. So apart from that, I mean, the big structure here is that it's a pretty standard REST-y sort of endpoint, right?
And how would you actually define that over in the YAML? Can we just actually, a lot of this stuff is YAML, or I think it can be JSON as well, but YAML seems to be the standard convention. So like, how would that, what does that look like in the actual YAML?
So what we should be able to do here, it's all a bit indirect, right? Like you usually have a section at the bottom for the models as well. So if we go and find sticker catalog endpoints, API stickers v1, so this is the base of the whole API. Then we have get stickers in the catalog. If we go down, we're going to find a reference to the response body.
Yeah.
And this is cool because it gives you a bit of indirection so you can reuse the submodels for different endpoints. So if we chase that down, we end up over here. Sticker catalog response is an object. It returns an array of stickers.
Yeah.
Each sticker is a sticker metadata. And you can see what I mean with reuse here now, in the sense that getting a single sticker is going to return a very similar model to getting all stickers, potentially exactly the same, depending on how the model is. If we chase that a bit further down, we should be able to find sticker metadata. So it's an object. It has a set of properties. We can mark up whether or not they're required. And we can put descriptions on them as well. For instance, here we've kind of overloaded an integer to say that -1 signals that it's effectively infinite on the sticker quantity remaining.
And this is where it becomes really, if we imagine that I was building something that needed to integrate with your sticker service. I have everything I need here, maybe apart from like authentication, which the OpenAPI spec does support documenting authentication as well. I have everything I need here, right, to be able to integrate with you without needing to talk to you, unless of course there's something that I need. Maybe I need the sticker price, for argument's sake, right? Then obviously that's not there, and then we would need to have a conversation.
Yeah, absolutely. And I think what we're talking about, using the OpenAPI stuff rather than kind of the shape of it briefly, it's worth mentioning that pretty much every programming language that has a way of exposing REST APIs can generate all of the model stubs and the API controller stubs from these files now. And you can often even round trip it. For instance, with Quarkus, you can generate an OpenAPI spec back out from the actual definition of your application. So you can use that to close the loop and keep things synchronized up.
Yeah, if we just have a quick look at that in .NET, for example, because me trying to shove .NET into as many places as possible is kind of my life goal.
Where's the Rust? This is pointless.
Where's the I should have definitely. I don't actually know if there is an AutoGen SDK for Rust. Like I'm sure there is, but yeah, in .NET it is like a fundamental part of ASP.NET, which is the .NET Web Framework. So here we've got these 3 lines of code where and the middle one there, add endpoints API Explorer, and then we've also got the use Swagger. So that them 2 things combined there will cause at startup the framework to look at all of the endpoints that the API exposes, which are just methods in .NET, and it'll look at the request parameters and the response of the method, and it will use that to auto-generate the OpenAPI spec.
Now that we've talked about kind of the meta bits around the tooling, maybe we can have a look a bit at what we think the core part of the API is for the purposes of progressing these in parallel. And it's cruddy, right? Like it's create, read, update, delete. There's pretty typical ways of structuring these. If you think of things as being RESTy these days, you can have lots of APIs that are a bit harder to map back. For instance, if you have an API where you can ask the service to do things for you, say. So you're not just doing create, read, update, delete. You're like saying, go off and start this operation. You have these big discussions about whether or not the request is creating a resource or if you want to make it more procedural. But in the case we have here, it's very straightforward. We have stickers. We have an endpoint to fetch them all. It's paged. We have a post endpoint to create new stickers in the catalog. This will return let's have a look, a 201 created, which is good. We've got the right response codes on there as well. We have get for individual stickers. We have put to update an individual sticker. You might also want to add a patch there, but I don't think we really need that, where you only want to replace some subset of the fields. And then we have a sub resource for the image for the sticker. So the stickers are comprised of metadata about the stickers that you see in the core models, as well as the image of the sticker itself. And what you would hope to see, if we've designed this well, is that from here, you get an image URL. So you have a nice way of chasing down the related object now. And this brings me back to my point before. When you do things in this fashion, we need to put tooling in place so that we know that the documented specs reflect what's actually in the code base.
Yeah. And this is where having like some element of good stuff, I think there's probably some further work we need to do here to.
Yeah, absolutely. I think we should be failing
that auto-generated spec. Yeah, exactly.
But I think this is super inoffensive. Like it's a straightforward API. The structure is something that we could easily chase out for another one of the services, for the user management service, for instance. We have enough here that it should be obvious how the specs of other services follow in the same pattern, which is what we want.
Yeah, and we should, as I said at the start, now be in a place where we've gone from that domain story, really high level, what does the app actually do from a business perspective, what problem is it solving, to the event storm, which is slightly deeper, looking at the flow of events in the system over time, and then the commands and the queries that trigger out that event. And then now we're almost at application code. We're actually starting to map out what does the actual API need to look like that facilitates this event storm, that then facilitates this domain story. And I think that's the benefit of starting to do all this stuff.
Exactly. And we could literally take this spec and go and create a new Quarkus Java application and say, generate the API backing from this, and then just color in the dots.
Yeah. Yeah. Awesome. Well, that covers synchronous APIs. Maybe in our next video, we should talk about asynchronous APIs.
That sounds very sensible. And it's kind of obvious to do it in this order because most of our interactions to get things working are going to rely on the synchronous APIs initially because of how you described the division of responsibilities between them. So we could get going with the synchronous APIs and have something testable and then bolt the asynchronous stuff on this subsequent step.
It also benefits as well in a lot of organizations I've worked in, at least, that the front end sits somewhat separate in the mythical world of JavaScript, unless you're doing some crazy micro front end type stuff where the front end sit with the individual teams. A lot of orgs I've worked in have front end teams. And I think optimizing for synchronous first helps unblock things there as well. Like if we can spec out our API and say, here, front end team, here's what the API is going to look like, those mythical JavaScript developers who do crazy things and make things look pretty can go off and actually start working, which is also super cool as well. Cool. Well, we'll save that for the next one.
Sweet. Have a lovely evening, James.